And so for the demos, I'm going to run 3 videos. And one is about installing PernixData, and I want to show you how simple it is to get going. The other one is about configuring Flash clusters and adding devices into the virtual machines, consumers to the Flash cluster. And again, I want to show you how easy it is. And then we'll visit a system that has been running for a while and see how one can monitor the system, what kind of data comes out of the system for someone who wants to troubleshoot in case things go wrong. They never do, but we all know that. And then the last part is we'll do a live demo, just to square up some of the rough edges, or in case you guys want to see things that are not part of the demo. So I'm going to take this is a Virgin vSphere system. It has Virtual Center, 2 hosts, and we are going to start from scratch. It hasn't been Pernixed yet. There is absolutely no software from PernixData that runs yet on the system. So here we are logging into vSphere client. And just for completeness sake, there's the 2 hosts. And they have a bunch of machines. So you go to Update Manager. PernixData ships offline bundle that you can add to your WUM repository. So that's what we are doing right here.
The computer's hunted.
I'm sorry, what was that?
The computer's hunted. It's moving all by itself.
Exactly, right? How about that?
He's using mind control. It's a Windows new feature.
I knew Satya was a smart guy. That's what I expected.
Well, I guess I'm smart enough to capture a video instead of trying to do it live. But and so, I mean, this is very ironic. It's going to take longer to add PernixData as a repository and all that good stuff, which is happening right here, than to actually install it.
Apple is going to have mind control in Mac OS House Cat. But then they'll claim that they invented it.
But we know the next version is going to be called House Cat.
Definitely.
I thought the next version was Persian.
Iranian, okay? Iranian.
No, the people are Iranian.
Okay.
Actually, the people call themselves Persians.
If they don't call it Ocelot,
Okay?
What's that?
if they don't
What do
call
you
it
got there?
Ocelot, they're missing a good.
Exactly.
Hey, there's something going on the screen.
While you are talking, we just installed everything. So so yeah, that is fast. Well, I guess I need to do one thing, which is so far, just to bring you guys up to speed, we just did the non-interesting part, which is we added PernixData offline bundle as a component that ESX hosts in the cluster can install. And so now we are going to scan those ESX hosts, and the next thing vCenter is going to say is these things are out of compliance because they are not running PernixData. And so the scan's complete. You see there's the out of compliance warning, so you say remediate, and a few more clicks, and you can install PernixData on all hosts in the cluster. I was going to say 1 click, but unfortunately it takes 5 clicks or something. But that's about it. It's doing its thing, and
No restart or?
no restart. The hosts need to be in maintenance mode, of course, but that's about it. Next thing, we are going to install the PernixData management server. So the way to think about it is this is like the vCenter analog. It mines data from all the PernixData instances that are running on the ESX machines themselves. It is not a mission critical part. In other words, it may go down, but all virtual machines that are accelerated, they keep on doing their thing. You can connect to hosts through the Power CLI stuff and do your thing, etc. But this is what our UI uses, and this is the backend for our UI. This is how we collect stats. We store it in a database, and so we are going to install it. All you need to do is have the credentials to vCenter and our database handy.
Is this installed on a bare metal, or is it installed in the ESX?
we can't afford bare metal. So right now we are installing it inside a Windows VM. But
I mean, PernixData.
It's on the
PernixData,
VMware host.
the actual core is installed on ESX hypervisors.
Okay.
And then this is the management part, which is installed in a Windows machine, any Windows machine of your choice.
Can it share the same SQL
The
server?
management one isn't in the center also.
Can it share the same SQL Server instance as vCenter?
It can. It can.
And it doesn't work into vCenter.
Oh, I guess I was just going to say that, on the screen a few seconds ago, you could specify the database you wanted to use, and so it could be the same as vCenter or a different one. Sorry, Enrico, you had a question.
No, isn't integrated in the vCenter?
Oh, right. So what it's doing is it asks for vCenter credentials. And so next time I log into vCenter, it has already talked to vCenter saying, look, I'm PernixData. And so now our UI is a vSphere plugin, vSphere client plugin. And so next time you log into vSphere client, vCenter is going to tell vSphere client that you have another potential plugin that you can install. So we go to standard plugins tab, and there you have another available plugin, which is from PernixData. A few more clicks. By the way, guys who have the beta or who are watching at home, this is something your beta doesn't contain.
So while we're waiting for it to install, how does it fit in with other plugins that split writes like Zerto in the stack on ESX?
Right, so I'm less forthcoming about that because we just came out of stealth. But let me just say that we don't use the same architecture that Zerto does.
Okay.
I'll tell you that. And so there it is, the plugin's installed, and now there would be a PernixData tab that one could visit. There it is. And so it's as simple as that. So, in a matter of around 5 minutes, we installed host extensions, real core, on every ESX server in the cluster. We installed the management piece, and then we installed the UI. Now we are ready to go, which is the next demo. Now I made a small error producing this video. I left out the part that actually creates flash clusters. So we're going to start with a flash cluster. So let me pause it here. This is the UI. I click get started, and we get into this page where you can create flash clusters. Now there's multiple ways to think about it. So for example, you can have a flash cluster in your data center, which is your tier 0 cluster, and that's maybe made of really high-end PCI devices which have less failures, etc. And maybe you have another tier 1 flash cluster, which is maybe SSDs that you bought off of Amazon and that are not on the HCL, and so on and so forth. So that's the reason you might actually have multiple flash clusters. You might have a flash cluster off of eMLC devices, which are much more resistant to power failures than, or much more correct in case of power loss than MLC devices, and so you can segregate that way, whatever. In the general case, of course, all that said, we expect people to have one flash cluster and be done with it. And so in this case, what we did was the stuff that didn't make it to this video is we said, create a flash cluster. I gave it a name, and then I say add devices, and then it lets me. Actually, when we visit the live demo, we'll probably look at that UI, but it gives you a list of all the devices that you have across all hosts. And you click, and then bam. There are multiple devices across hosts that are now stitched together into one flash cluster. There is no networking to be configured. It is as simple as that. So that's the resources that the flash cluster has to use. And the next thing you do is add consumers to that flash cluster. And so in this case, we have a 2-device flash cluster across 2 nodes. You can see those IP addresses on the right. There's the topology, 2 hosts, each of them having 1 flash device. And right now it's idling. There are no consumers. And so we go to configure again, and this time around to data stores and VM. Now, if you're a big shop which has hundreds of VMs or thousands of VMs, you can add entire data stores at a time. That's a much easier way to just get your business done and get out. Once the data store is added, every new VM that is going to be on that data store will automatically be accelerated. So it's like a bucket that you have accelerated, and you can keep on throwing more stuff into that bucket. If you care to, you can add 1 VM at a time. And so, for example, out here, we added 2 data stores, both in write-through merge. You can choose that policy while you add them or at any other point in time in the future. And so next thing we'll do is probably add a few VMs to that data store. And this time, since we are adding by VMs, now you'll see some of the VMs are already added to the flash cluster by virtue of the data store that they reside on. And so then there are some other VMs that are candidates. So you can click on those. And this time around, we are going to add them in write-back mode. When you add the VM in write-back mode, you get to choose the degree of replication that you want on that particular set of VMs. And in this case,
the default is live dangerously?
I'm sorry?
And the default is live dangerously?
Yeah, well, actually, it's funny. In the beta that we sent out, the default was two nodes. You know what happened? Everyone runs this with 2 peers, and so you really need 3 nodes. Well, everyone runs this with 2 nodes, and so now the default is 2 peers, and you chose write back, but we'll see that there is no way to actually satisfy that policy, and so you don't write back. And so anyway, little stories. But there's one thing that you must have noticed is the flash device with 2 remote flash devices was grayed out because it's just a 2-node cluster. So you can choose 0 or 1 peer in this particular demo.
If one of the hosts, sorry to interrupt your video, but if one of the hosts had 2 cards, would that be 2 peers in one host and 1 peer in another? Or is a peer another host?
Peer is always a fault domain.
Okay.
And so it is always another host.
Okay.
This thing is just too hard to isolate the fault domain if the host goes down.
That makes more sense.
Servers aren't reliable enough for that.
That's the point I'm trying to drive.
Right. All right, so that was that video. Now the last video, and then we'll jump over to the demo and the live demo, is we are going to visit a system that has been alive for a while. This is a slightly bigger system, 5 nodes. These are all Cisco UCS systems, thanks to our friends at Varo. And so let's see, look, press play. So just FYI, we are showing the configuration for this system. That's a Cisco UCS. And I don't know why he's showing it again, maybe just showing off at this point. But that's a blade. It's a combination of boxes and blades. Yeah. And then we are going to go to the PernixData tab. Some VMs have already been running on this. So it's a 5-node configuration. One of the hosts has 2 flash devices, as you can see. The other ones have 1 each. And this is all stitched together in 1 flash cluster. There's 17 virtual machines that are currently added to that cluster, all of which are active. Right now, they are driving approximately 71,000 IOPS, 292 megabytes a second at 91% hit rate. The last thing is how many IOPS we saved since we started this system. Now, this is interesting. This is like, this is what demos come down to, right? They come down to the wire. He started this system yesterday afternoon at 4 o'clock. 4 hours later, we've saved 1.4 terabytes of data from going to the SAN. And we've saved approximately 375,000, million commands from going to the SAN, out of which 42 million were write operations. Now, of course, we haven't saved we have accelerated those write operations. So I'm sorry. So that's the status of this system.
Now, if I can only get EMC to charge me per IOP and then put the cache
You-
in, I get a huge
yeah.
discount.
That's true. If servers were to ship with credit card, readers, then we did have a licensing model in mind. To Enrico's point, is you swipe the card once, and that way we don't have a performance problem either. Is it's as fast as your monkey can swipe the card.
New version of Shadow IT, just swiping the card on the array.
Exactly, and yeah. We wanted to do SMP, 2 card readers.
All right.
So moving ahead, so that's a summary. And the way the UI is designed, this is what I'm most proud of. And we put a lot of thought into what makes sense to show. Like, why is the customer even here? Is when they have a problem. And so typically they never go past that first page that I showed you. Is things are going on and we are giving you a summary information of what it's doing. If you are happy with that, you don't need to go to this part. But if you do need to dig down deeper, then here's actual IOPS and latency stats from the system. Now there's so many stories I can tell you here. Let's see, 1 hour? Okay, we have enough time. But the IOPS, as we already saw, the system's doing somewhere in the 80,000 IOPS range. And the orange curve is IOPS from the local flash device. The green curve is IOPS from the remote flash device. The purple curve is IOPS from the data store. As you can see, the flash device is doing most of the IOPS. The data store is not doing too much traffic, and hence it has extremely low latency. Now, that's the beauty of the, that's the problem with doing a kind of, a planning thing, because the data store would be much worse, except we are saving it from being worse. There is another very interesting thing. Well, first of all, the network is doing a lot of IOPS. It is not very apparent because of the scale of the graph, but the network is somewhere in the, I would say 9,000, I'm sorry, 6, 7, 8,000 IOPS range. And actually not many vMotions are going on. So this is probably just one virtual machine that moved around or something. In this case, actually you'll see an anomaly. Is the network latency is slightly higher than the data store latency. And it turns out it was a real bug in this setup. Is they have one big flat network which is shared both for data and management, and which is not the greatest thing in the world when you're running so many things. But anyway, that's one interesting system that I had to show you. Apparently there's some more stuff here, so let's see. All right, so here's the hit rate curve for the same time range. And it's a read mostly workload, so IOPS are high. You can figure out if the hit rates are low, you can figure out which flash device is the culprit. It could be because of the flash device hardware. Not all flash devices are made equal, so you can debug that. But bottom line, you can actually see exactly what every component in the system is doing for you: the flash, the SAN, the network. You can pinpoint problems. Here's a heat map, so you can actually tell which VM is getting most share of the IOPS, and so if you have a problem, then you can tell which ones are the hoggers, which ones are the starved ones, and so on. And you can just zoom into those VMs. So that's roughly the UI. Now the part that we are not showing out here is you can do the same thing on a per VM basis. You can do the same thing on a per flash device basis. So same kind of IOPS and latency and hit rates, all those calculations. All right, now for the hard part. Maybe time for me to sit down. So I'll take you to a live system, which was also one of the ones used in capturing the demo before the Varo system. And this is again two nodes. There's I think 3 or 4 virtual machines running, a couple of them in write through, a couple of them in write back. There are 4 of them running. And this has already been configured with the flash cluster that we saw in the demo. So right there, 2 hosts, 2 flash devices, one in each host. And at this point in time, let's just say it's doing around 15,000 IOPS, 64 megabytes. And hit rate is pretty good. Latency is reasonable.
99% is pretty good.
This is a demo lab.
So let's see, what's interesting to show here. What I'm going to do is throw caution to the wind here, but before that, let's switch to an interesting view here, performance. So it's a 1-day performance. As you can see, we prepped for the demo here and here and here, and then we are running it. 1 hour maybe. Actually, let's look at 10 minutes. Okay, so now we are back to this is what the flash cluster is doing. You can't see the blue line because the effective IOPS, and by the way, the effective IOPS is what the application sees. And so, sometimes the effective IOPS is between what flash provides and the data store provides, because it's a combination of IOs that are going to the data store and IOs that are going to the flash device, and of course the network. So I think the easiest way for me to perturb all this stuff, this nice system, is I'm going to vMotion a VM. Oh, come on. So let's say I choose this VM, let's say migrate. All right, so that is how you vMotion VMs using PernixData. The most boring demo in the world, right? But that is the point of making this platform, is nothing changes. You can take snapshots the same way. These VMs don't have RDMs attached to it, none of that stuff. We make 0 changes to the VM configuration file. But anyway, so as the vMotion goes on, we'll see changes to the curve, because now maybe the network will kick in. While that's going on, we can take a look at the VMs themselves. So for example, this is the guy I just vMotioned. And, oh, actually, maybe I should show you this, is if we go to the host, that's a configuration of the host, a bunch of data stores, and the VMs are on these data stores. These devices come from various disk arrays. There's a Clarion, there's a NetApp disk array, there's an EcoLogic. And this particular VM that we moved was on the NetApp, right there. So this is interesting, by the way. There is no part of this page which realizes that the VM has changed configuration. There is no change to the configuration file. It still is hosting a VMDK on the NetApp LAN, and that's about it. And it's just magically faster. This is typically what gives some of our users a lot of confidence that the solution just works without perturbing a lot of their, a lot of the functions they rely on. Because if you don't change the VM's configuration, then well, maybe you are not going to come in the middle of anything. So there it is. You see the network pickup, that's a green line. It's doing approximately 6,000, slightly less than 6,000 IOPS. And so that's because one of the VMs just moved over, and PernixData figured out that the other device over the network has more data for this VM than the than the one that is running on this host. Now, while that VM is running on that new host, PernixData is also adding all that stuff that it reads over the network into the local flash device, which is why you are seeing that gap between the flash IOPS and the effective IOPS the application is seeing. That is the number of IOPS we are actually using to throw the data onto the flash device and onto the VM. In fact, it's pretty awesome, right? The gap there is the height of the network bar. So it's almost, what we are reading from the network is going into that device. Now I'm very excited to tell you that this is all running on beta builds. These builds have a lot of debugging thrown in. And so this is not even the most performance you are going to see out of PernixData. We do a lot of, random things like, CRCs and this and that, which actually cause a lot of, memory and I/O overhead. But it's pretty good as it is.
So the question that was in my mind, I saw it was on the Twitter stream as well, is how does this affect doing VA operations like a clone?
Haha, funniest thing. Let me show you. Actually,
you look pretty excited there.
no, because
kind of nefarious.
No, that's why we are doing this. It's like, how about for the first time ever, we make a server-side flash product that is not broken, and so it excites me, and it's a matter of personal pride, right? And for all the engineers at PernixData, for that matter. So let's go to the host here, and
good thing they just sent you. I think two would have been more
APIs.
I've got plenty of energy in this room.
VMware talk to the array.
so here we are on the storage pane again, and we said we are using this NetApp device. And if we go to the right, hardware acceleration supported. And so, this wouldn't be the case if we came in the way, if we changed anything with that device. In fact, it is so interesting that with NetApp, it turns out their VAI commands. Actually, I know this because I did VAI, but most of their VAI command set is what eventually got put in the SCSI standards. So it's one thing to say that is supported because we understand those VAI commands and it's all good. Well, it turns out there is a Clarion LAN as well right here, or let's say an Equalogic LAN right here, and for all of them, as you can see, hardware acceleration supported. This is, the Clarion doesn't do, at least, this version of Clarion. This is not the VNX, it is actually a Clarion. It didn't do standard-based VI commands, and yet it shows up as supported. So we don't perturb that. But yeah, no, thanks for pointing it out. In fact, I forgot to look at this view to start with.
How big is that bigger cluster that you have tested?
How big is the biggest cluster? We have internally, I would say probably 6 nodes or so. We have some other, data from other users which are slightly bigger clusters, but I'm afraid that's all NDA, so it's not worth talking about. When we
fire it up in the lab, though.
Sorry, come again?
I'll just have to fire it up in the lab.
Oh,
then.
go for it.
We can take you to 16.
Go for it.
So how do you plan to, sell this? I guess capacity-based, number of cards in there. I mean, do you have any ideas?
And just by virtue of my good looks.
Not actually market it, but how would I buy it? What am I buying?
So we don't want to do that mistake. Flash capacity is a moving target, right? A 640 gigabyte card looks like a very expensive thing this year. It's not going to look expensive next year. And so we have designed our pricing scheme such that people don't feel cheated when some of the obvious things happen, which is flash capacities go up, the core count goes up in the servers, the amount of memory, the number of VMs go up per server. We've designed our licensing not to get into those problems. I'll just stop at that.
Yeah, I was saying you haven't quite, but okay, not capacity.
Well, there's enough time to have a beer afterwards,
Okay.
right? So,
Fair enough.
Is there any idea when it might be GA'd?
Yes, very soon. I'll just say summer. for now. Should I? Yeah. At this point, I don't even know what I should be disclosing or what I shouldn't.
We'll just keep asking you questions.
Yeah, exactly.
Does it support NFS as well, or just fiber channel iSCSI and direct?
Right now, 1.0 is going to support fiber channel iSCSI and FCOE. And
So block,
in
basically.
summer, you can use NFS beta. Or anyone who is interested for that matter can use NFS beta. Any other questions, guys, before we move on from the live demo?
Question coming from Twitter.
Uh-huh.
How it affects other balancing solutions, just like storage DRS?
Ah,
Because we are changing the
Yes.
statistics that are coming out from the storage.
right. So let's talk about storage I/O control first, because storage DRS is a multifaceted beast, right? It talks about, it wants to do resource management for capacity and for performance. But SIOC is really that performance thing. So just roughly speaking, SIOC is looking for if your current behavior is anomalous with respect to what it measured already.
But you declare a threshold in milliseconds?
Yeah, exactly.
Thanks to your technology, you are faking the threshold on the data store.
No, so it turns out that it will actually measure the true threshold of the data store.
Okay.
And then we are accelerating it. And so if we are doing our job right, then it's not going to hit that threshold. And that's that.
So XXI goes on seeing the real threshold on the final data store.
I'm sorry, come again.
The XXI is going to see the real threshold
SI
coming out from the data store.
SIOC will see the real threshold.
Okay.
But our job is to always keep the VMs. As long as we keep it under that threshold, then we are golden.